This is the River Kelvin in Glasgow. And when the younger brother William Thomson was made a baron, he called himself Baron Kelvin of Largs after the river. Now in 1837, Cook and Wheatstone had pioneered the electric telegraph. And by the early 1850s, it was possible to send telegrams all over the empire, but not, unfortunately, to North America because of the Atlantic Ocean. But in 1855, William Thomson brought America within telegraphic reach. So, I'm going to lay a transatlantic cable. Well, actually a trans-Kelvin cable. At the other end, my cable is connected through a 1.5 volt battery to the Earth. So what I'm going to do now is to check and make sure it hasn't broken. This is what Kelvin did constantly. So with this, I'm going to connect to the Earth through the water. And with this end, I'm going to connect to the end of the cable. And yeah, I've got a lovely signal, so I know that my cable is intact. The first cable, laid from the Agamemnon, snapped. The second cable seemed to work, but they ignored Thomson's advice and used high voltage, which attacked the insulation. Only 732 messages got through. He used the Great Eastern to lay a third cable which broke after 1,000 miles, and permanent communication with the USA was finally achieved on the fourth attempt. William then set up the first ever physics laboratory here at the University of Glasgow. He was interested in heat. This rather grand room is now the Senate room, but it used to be Kelvin's laboratory. He was really interested in a heat phenomenon, first discovered and described by the French scientist Jacques Charles. What Charles discovered was that if you take a balloon full of gas and cool it down, then it shrinks. I've got two balloons here, as near as I can do, identical in volume, and I'm going to put this one into this beaker here, which contains liquid nitrogen at minus 196 Celsius. And he actually discovered that it shrinks for every degree you lower its temperature by 1/273rd of its volume. There, you can see it's shrinking away now. And Kelvin realized this was very odd, because if you cool it by 273 degrees, the volume should go to zero and the gas would have to disappear, and that was obviously impossible. And then he realized that he was thinking about it the wrong way. What he should be thinking about was the energy. Now inside here, there are loads of particles of air whizzing around with masses of energy, and it's that whizzing around that makes the gas take up space, that gives it its volume. And when you cool it down, they whiz around with much less energy, and so they take up less volume. And he realized that if it was cooled by 273 degrees, what went to zero was the energy. They had no energy. They were frozen solid. And so he called that absolute zero. And in honour of him, a new scale of temperature was created, which started at absolute zero and went up 1, 2, 3 in kelvins. So the boiling point of nitrogen is minus 196 Celsius, or 77 kelvins. When William died in 1907, he was buried at Westminster Abbey, next to Sir Isaac Newton.